This video is part 2 of 2 videos in which we're exploring geometry and measurement. The concepts about angles we learned in the first video will now be applied to understanding triangles, so you may wish to watch part 1 before watching this part 2. There are many places we see triangles in the world around us, for example in architecture. A couple of notable examples around us are the Bloedel Conservatory at Elizabeth Park and the TELUS World of Science. As we begin to explore triangles, our main purpose is to classify triangles into different types. Taking a look at this set of triangles, what do you think makes these triangles different from each other? These triangles can be distinguished by their angles. The middle triangle has a right angle, so it is called a right triangle. It has one right angle and two acute angles. The triangle on the right has an obtuse angle, so it is called an obtuse triangle. It has one obtuse angle and two acute angles. The triangle on the left has three acute angles, so it is called an acute triangle. But there is a second way to classify triangles. Identical markings mean that these sides have the same length. What do you think makes these triangles different from each other? The first triangle has three equal sides, so it is called equilateral. The second triangle has two equal sides, and it is called an isosceles triangle. In the third triangle, all of the sides have different lengths, so it is called a scalene triangle. Let's apply what we have learned about classifying triangles with a few examples. The first way we classified triangles was by their angles, and the second way was by their sides. But for any one triangle, we could look at both its angles and its sides. For example, this triangle is both acute and scalene. What other combinations are possible, and what do they look like? Scalene triangles can be acute, right, or obtuse. The same can be said for isosceles triangles. But an equilateral triangle can only be acute. It is not possible for an equilateral triangle to be right or obtuse. For the next problem, we are given a pair of angles for two different triangles, and we are asked to determine which type of triangle it is. Because we are focusing on angles, the possible answers are acute, right, or obtuse. Recall that the sum of angles in a triangle is 180 degrees. These two angles add up to 90 degrees, so the third angle must also be 90. So it is a right triangle. In the second triangle, the two given angles add up to 78 degrees. So the third angle must be 102 degrees, so this triangle is obtuse. In our final problem, we are given that a triangle has a perimeter of 18 centimeters. The perimeter of a shape is a measure of the distance around it. For example, in this case, the perimeter would be the sum of 5, 8, and 10 centimeters, so its perimeter is 23 centimeters. Back to the triangle with a perimeter of 18 centimeters, what could its side lengths be if the triangle is equilateral? What if the triangle is isosceles? If the triangle is equilateral, all three sides are equal. So if we divide the perimeter by 3, we see that the dimensions must each be 6 centimeters. An equilateral triangle is also isosceles because it has at least two sides equal. But what other possibilities are there? There are many, But what must be true for all of them is that the three sides must add up to 18 centimeters. And two of the sides need to be the same length. One such triangle has 7, 7, and 4 centimeters. Another one has 5, 5, and 8 centimeters. But what if we started with two 4-centimeter sides? The third side would need to be 10 centimeters so that the perimeter is 18 centimeters. But the two small sides are not large enough to make a triangle with the large side, so this triangle cannot exist. There are many other possibilities, especially if we consider decimal lengths. This video addresses several learning standards in the Mathematics Grade 6 curriculum. This big idea emerged frequently as we described and compared triangles. In content, we looked at triangles. In their classroom, several curricular competencies may emerge as your child learns about triangles. Reasoning and logic were used to classify triangles, and these mathematical ideas were applied to solve problems. And there was a lot of mathematical vocabulary developed to be able to classify triangles. We hope that you found this Part 2 video valuable in helping you support your child in their learning about triangles. Be sure to check out the other titles in this series.